Hi all. So this is another problem, which is the assessment problem 4.11, in which we have to find the value of this current IA by using the mesh current method. So this is another problem in which the branch current in a circuit is given. So here we should identify the number of meshes. So again, we have 1, 2, 3 close paths or meshes here. So after allocating or recognizing the meshes here, we have to allocate some currents here. So here let me call it I1, this current here is I2, and again the green one is selected for the mesh number 3, and this is I3. Okay, so in this circuit we are given some quantities here, and one of those quantities, or one of those given quantities, is this dependent current source. Okay, the voltage dependent current source, and the voltage which is given is here. So here we know the value of I3, which is basically again here, and the value of I3 is again minus 10 amps, because this is the only branch current which is flowing here, and the direction of this 10 amps is opposite as that of the supposed current, okay, which is in the clockwise direction, while 10 amps is in the counterclockwise direction. Similarly, the value of V phi, okay, we can see here that as the polarity is here this one, so the value of V phi is basically 5 into the excuse me, 5 into the I1 minus I2, and similarly the value of I2 is also known here, and the value of I2 is again this is the only current here, so the value of I2 here is the 2 V phi divided by 5. So these are some quantities which we know from this circuit. These are basically hidden in this circuit, and you can easily recognize them if you have enough practice over the mesh current method. So now after finding the values here, let me solve it by using the mesh current method and considering the mesh number 1 here. So again mesh number 1, and applying KVL here, we will have voltage source 75, and the value here again is the voltage rise. Similarly the V2 here and plus V5 both are the passive elements, so the voltage across them is the voltage drop. So V75 is basically our 75 volt source, V2 is 2 I1 minus I3, and V5 is basically 5, and I1 minus I2. okay, so now rearranging them, 75 is equal to 2 I1 minus 2 I3 plus 5 I1 minus 5 I2. okay, so now as both of these sides are equivalent, so adding them, adding the two terms here, then minus 5 I2 and then minus 2 I3, and the value of I3 is basically given here, and that is minus 10 equal to the 75. okay, so now it would become 7 I1 minus 5 I2, and this would become the plus 20 equal to 75, which will ultimately give me, moving it to the other side or subtracting 20 from both sides here, we can see here that this would become 5I2 equal to 75 minus 20 is the 55. So this is my equation number 1. okay, so this is my equation number 1. Now moving towards the mesh number 2, and we already know that the value of I2 is known here, and that is 2v5 by 5. Okay, we also know the value of v5, which is also given here, and putting the value of v5 here, we will get the 5 multiplied by I1 minus I2. These two will cancel out, and I will get the I2 equal to the 2I1 minus 2I2, and ultimately moving it to the other side, we will get 2I1 minus 3I2. This is equal to the 0. So this is equation number 2. Now we have two equations, two unknowns, and we have to find the value of IA. So as this is the linear system of equations, so now we have the linear system equations. So now multiplying 3 with the first equation, okay, 3 with the first equation, and then 5 with the second equation, and then subtracting the second equation from the first one, I will get something like this one. So the multiplying 3 with this equation, equation number 1, I will get 21 I1 minus 15 I2 equal to the, this would become 165. Okay, similarly now multiplying 5 with this one, I will get 10 I1 and minus 15 I2 equal to 0. Okay, so now we have got these two equations, and for subtraction we have to change the symbols here. So these two would cancel out, and here I will get the 21 minus 10 is 11 I1 equal to 165 minus 0 is 165. So ultimately I will get I1 equal to 165 by 11, and that is equal to the 15. So the value of I1 is a 15, and we can simply see here that the value of the IA is basically the value of I1, which is the same current here. Both are in the same direction. The supposed current and the current which we have to find out are basically the same, are the same direction, and therefore the value of IA is the 15 amps, and that is the answer of this question. So again we can see here that here we discussed another problem in which we had two branch current sources, and one of them was the dependent source. So I think it's enough and clarified your concept, and I will see you in the next video. Till then, take care of yourself, and thank you so much.